I have a question. Di ba we have the integral of x raised to n dx? So there is an integral for this, and that is the x raised to n plus 1 all over n plus 1 plus c. And that is for different values of n. Okay, so whether that's negative integer, positive integers, or whether that will be a fraction, positive or negative. However, there is an exemption to this rule. So what values of n wherein we cannot use this formula? That's the value of n wherein we cannot use this formula. Tingnan mo yung formula itself. Okay? So na kapag ginamit ko yung formula na yon, it will lead to undefined solution. So what is the value of n? 0? Kasi kung 0 yan, x raised to 0 dx. What is x raised to 0? It's 1 dx. Ang derivative, anong integral ng 1 dx? It's x plus c. Okay? So, hindi siya 0. So 0 is defined. Okay? So kasi x raised to 0, it's 1. Its integral, it's x. Okay, so very good, Jesse. So it's negative 1. Okay? Kasi if I would have x raised to negative 1 dx, so that would be x raised to 1 or negative 1 plus 1 all over negative 1 plus 1. So negative 1 is okay lang sa taas, x raised to 0. Sa baba, it's 0. So this is 1 over 0. That makes it undefined. Okay, so that is the exemption. Okay, so that's the only exemption in using the power rule. Okay, so when x is negative 1. So, sir, paano pag ganoon? Okay, so, dito tayo pumapasok. That is the integrals leading to natural logarithm. So the general power rule, so we cannot use when, or we can, n cannot become negative 1 because it will yield to an undefined solution. So that is why we are using this formula for the natural logarithm that the integral of 1 all over x dx multiplied with dx, that is equivalent to ln x plus c. So that is for x. However, if we are given a function, okay, so let's u is a function of x. So therefore, the integral of 1 all over u, multiply it with du, is equals to ln u plus c. So pwedeng it's just as simple as x, dx over x, it's ln x. However, if it is a function, we can still use the ln, okay, or the natural logarithm. So what's the idea with the natural logarithm? So the idea in the natural logarithm is that if I am going to derive the denominator part, and then I'll get the numerator part, then that is a natural logarithm. So yung kanina kasi it's product, di ba? So u raised to n. So if I derive u, and I'll get, okay, so the other part of the product, then I'm going to use the power rule. But in natural logarithm, usually kasi natural logarithm, they are always a rational function. Okay, so rational expression sila. So tingnan mo yung denominator, then once you get the numerator, then that is a natural logarithm. Another thing, its power is equivalent to 1. Okay? Kasi it's u raised to negative 1, di ba? It's u raised to negative 1, or simply 1 over u. Okay? Or that is just simply 1 over u. So pag ang power niya, it's just 1, then possible. One of the solution will be natural logarithm. Okay, so let's have our first example. So for our first example, so again, look at the denominator. So pag wala siyang a function raised to a certain exponent, okay, so greater than 1, then possible. Okay, possible lang naman. So that is a natural logarithm. Kasi that's the idea in integral calculus. It's a trial and error. So you have to take a look at it first, and then afterwards, ano yung unang hunch mo to solve it. Okay? Then you try it. So if it doesn't work, you have to do another method. In this case, so since this is a ratio, so I'm going to assume that my u is 2x cubed minus x plus 1. So once I derive it, so that will be 6x squared minus 1. And multiply it with dx. And so happen that it's exactly the same. So this is 1 over u. Ang u natin is 2x cubed minus x plus 1. Then multiply it with du, so which is 6x squared minus 1 dx. So what's our formula? That is 1 over u du is equals to ln u plus c. So the one on the right-hand side, so this one, it's the same as this. Okay? So in this case, there's no need for neutralizing factor because they are exactly the same. So right away, we can now write that that is ln of 2x cubed minus x plus 1 plus c. So that would be our answer. So ln of 2x cubed minus x plus 1 plus c. So that is natural logarithm. Question. Okay, so kuha pa. Second one. So again, u. So since natural logarithm to, yun sa baba ang u natin dyan. Okay. So 2x squared plus 3x minus 5. So derivative, so 4x plus 3. So anong difference nito? So look at this. So di ba the integral natin would be 1 over u. Supposedly ang u natin is 2x squared plus 3x minus 5. But then, so supposedly, ang susulat ko dito should be 4x plus 3. Okay? So it will be 4x plus 3 dx. Is this the same as the original integrand? So u natin is ito. Ang du natin is 4x plus 3. But on the original integrand, it's 8x plus 6. Tama?
Yes po.
Pero hindi sila parehas. What are we going to do? We have to neutralize it. So this time, mag-asawa neutralizing factor. One half. So pag ginawa natin 1/2 yan, what would happen here? Are they the same? Hindi, it's 2. Okay, so this is what makes it different. Okay, so the neutralizing factor here, it's 2. Why? Yung kanina kasi, ang sobra is the differential du. So siyang sobra as compared to the integrand. So kaya magbabawas tayo kasi sobra yung du. Okay? Kaya 1 over whatever would be the coefficient. Pero in this case, ang sobra is yung integrand. Okay? So sobra siya ng 2. Diba? Kasi pag minultiply ko yun, 2 times 4x is 8x. 2 times 3, that is 6. So that's why our neutralizing factor, it's 2. Okay, so we have to balance it out. So not all of the time, it is the u, so which is in excess. Okay, so in this case, it is the integrand, which is in excess. So if the integrand is in excess, our answer is greater than 1. Okay, so if it is the differential is in excess, our neutralizing factor is less than 1. Okay, so therefore, so what would be our answer here? This is 2, and then ln of 2x squared plus 3x minus 5 plus c. So if you want to raise that one to 2x squared plus 3x minus 5 raised to 2, that is okay. If you're going to apply the properties in logarithm. Pero kung ganito siya, okay lang. Kasi there's no sense naman, di ba? Masisimplify pa siya. Okay, so did you get it? So why we have a neutralizing factor greater than 1? Kasi it is the integrand, okay, so which is in excess in comparison to the differential du. So unlike with our previous example, it is the differential du which is in excess as compared to the integral. In those cases, the neutralizing factor is less than 1. Okay? Next. So this is another ratio. Kaya lang, pag ang u natin is x squared plus 5x, our du will be 2x plus 5. Will there be a way that it will become an x plus 3? So there's that. May common ba sa 2x and 5? Actually, there's none. Right? Kasi 2x plus 5 is not even factorable. So there's no way for us to get an x plus 3 at the numerator. Labas ko yung 2. Pag nilabas ko yung 2, so this one would be x. This would be 2.5. So hindi sila parehas. That is x plus 3. But what we have is only 2.5. So what would you suggest? Negative 2. Ganun din. Actually, ano lang to? It's just it's a trick question or problem. So not all of the case kasi na, yun nga, no? Pag dinerive mo yung denominator, makukuha mo yung numerator. Hindi lahat ganon. Okay? So pag hindi siya ganon, you have to abandon the idea that that is a natural logarithm. Okay? So probably you may need another approach. So another approach is, sabi nga, if can we perform the operation? We cannot perform kasi we cannot divide x plus 3 by x squared. Kasi this is an improper fraction. Mas mataas yung degree ng denominator. Or sorry, this is a proper fraction. Mas mataas yung degree ng denominator sa numerator. But actually, there are cases like this. Just so happen na yung denominator is factorable. So So, ano yung factor ng x squared plus 5x plus 6? It's x and x and
2, 3.
2 and 3. So it's plus and plus. So x times x is x squared. 2x plus 3x is 5x. 2 times 3 is 6 dx. Then x plus 3 and x plus 3 will be cancelled out. So leaving us to have 1 over x plus 2 dx. So ang u mo is x plus 2 and du mo is dx. So this is our u, du is dx. So I can now use the natural logarithm. So the answer is ln of x plus 2 plus c. Yun yung problema. Pag di mo naisip yun, patay. Okay? So you have to think. Okay? So it's either do the division, perform the operation, factor it out, completing the square. Okay? So para lang ma-forma siya doon sa mga formula natin. Okay? How about number 4? What is our u here? Can we use x, ln x? Pag dinrive natin yan, that is product rule. U dv plus b du. Ang u natin is x, u, dv. Derivative ng ln x is 1 all over x. Then plus b ln x. So derivative of x, that is 1. So that is cancel 1 plus ln x. dx lang yung nasa taas. Okay? So, di pwede yun. So what are we going to do? So there are cases that not the entire denominator should be your u. In this case, our u is just actually ln x. So once I derive it, so derivative ng ln x is 1 over x dx. 1 over x dx. Now, titingnan natin ito. This is the same as integral of ang u natin is ln x. Then derivative natin would be dx over x, which is the same as this. Dx over x. So we'll have 1 all over u, so 1 all over ln x, and then the derivative of ln x, it's dx over x. So therefore, what's the answer? It's ln of ln x plus c. Ln of ln x. Okay? Na-shock kayo ah.
Sir, that again po.
Ano na? Sorry? Ulitin? Hello? Wala, hindi ko naririnig yata. Yun. So parang ang pinaka ano natin yan, ang u lang natin is just the ln x. So this is just our u, ln x. So ang derivative ng ln x, it's dx over x. So ngayon, di ba ang formula natin kanina that is the integral of 1 over u du equals to ln u plus c. So ang u natin is this one, 1 over ln x. This is the 1 over ln x. And then ang derivative niya, it's the dx over x. So therefore, it resembles this formula. This is 1 over u, the derivative of u, the ln x, it's dx over x. du is dx over x. So follow this formula. ln, and then ang u natin is ln x. ln of ln x plus c. Okay? So next. Okay, I have a question with this one. Ano yung difference? Look at the example number 5. In terms of the degree of the numerator and the denominator. So for example 1, so we have, this is a second degree, third degree. Sample number 2, first degree, second degree. Sample number 3, first degree, second degree. Example number 4, okay, so this is not linear. Sample number 5, it's second degree and first degree. So anong difference nila? Yes, Samuel.
Mas mataas po ngayon yung numerator
Sa denominator.
sa denominator.
So yung kanina, ito actually yung clue when to use natural logarithm. Okay, so if the difference in the degree of the denominator and the numerator is 1, then possible that that is a natural logarithm. So second, this is 3. So this is third degree, this is second degree. So difference nila, it's 1. So this is first degree, second degree, difference nila is 1. So this is first degree, second degree, difference nila is 1. So as long as ganun siya, okay, so that would be a natural logarithm. Pag ang difference nila, it's 1. Okay, kasi pag dinerive mo yan, bumababa lang kasi ng 1 degree yung sa numerator, di ba? So that makes it the natural logarithm. Pero kapag ang denominator mo, it's an, or if the fraction is an improper fraction, so meaning the numerator, the degree of the numerator is greater than that of the denominator, and then we're gonna try to use natural logarithm. Okay, so what are we going to do? So we need to divide it first. We need to divide it first. Okay, kasi improper fraction siya. Okay, so what are we going to do? So long division na lang tayo. No? So x squared minus x minus 2 divided with x minus 3. So how do we divide? So ito muna. So x squared divides x. It's x. So x times x squared. So x times negative 3, negative 3x. Tapos we change the sign. So this one would become negative, this one becomes positive. So x squared minus x squared is 0. So negative x plus 3x is positive 2x. So ngayon, we divide again. So 2x divides x, that would be positive 2. 2 times x is 2x. So 2 times negative 3, it's negative 6. So we bring down the negative 2. So we change sign. So this is negative, this is positive. So 2x minus 2x is 0. So negative 2 plus 6 will have positive 4. So therefore, we can now write this one as the quotient, the integral of the quotient, which is x plus 2, then plus the remainder. Ang remainder natin is 4. Okay? So divide it with x minus 3. So ito. So quotient plus the remainder divided with x minus 3. The divisor. No? And then multiply it with dx. So ngayon, this is just simply, so we could have the sum and difference rule. So x dx. Tapos plus, ito, 2 the integral of dx. Then plus 4 the integral of 1 over x minus 3 times dx. So this is x squared over 2 plus 2 the integral of dx is x. Then plus 4. So x minus 3 sa baba. So derivative niya, it's dx. So ln lang yun. No? ln of x minus 3. And then plus c. Okay? Balikan nyo na lang yun sa ano natin, discussion. So medyo time na. So let's have the last example. So for the last example, so this is actually a trigo. There's a formula for this. So once we proceed with the integrals of trigo functions. However, so this one resembles a natural logarithm. Kasi for trigo functions, so we use identities. So remember that the identity for tangent, so the tangent x is the same as sine x all over cosine x. So therefore, we can use that one. So this is sine x all over cosine x dx. Then we let u to be cosine x. So its derivative is negative sine x dx. So kamukha nung kanina. So we'll have, so 1 over u, so 1 over cosine x. So matitira, du, it's negative sine x dx. So it's different with the original integrand. So we multiply it with negative 1 or neutralize it. Neutralizing factor is negative 1. So therefore, we'll just have a negative ln of u, which is cosine x. Let's see. So that's why we have the integral of tangent x to be the negative ln of cosine x plus c. Okay? That is our okay, so itong test knowledge, include it on your assignment. So make it number 11. Hindi natin matapos. So include this one as number 11 okay, so in your assignment.